Hey there, meteorologists. Welcome back to science class. Today we are going to keep talking about weather, but more importantly, we are going to keep thinking about that playground problem from last week. We're going to investigate to try to see if we can find out how sunlight might affect the temperature of a surface. So let's jump right into it. I want you to take a few minutes to go ahead and enjoy our weather song.
Check out the weather, what's it like outside? Check out the ground, check out the sky. What word would you use to describe what you see? What is the temperature, how many degrees? Is it sunny when you look outside? S-U-N-N-Y. Is it cloudy when you look outside? C-L-O-U-D-Y. Is it rainy when you look outside? R-A-I-N-Y. Check out the weather, what's it like outside? Check out the ground, check out the sky. What word would you use to describe what you see? What is the temperature, how many degrees? Is it windy when you look outside? W-I-N-D-Y. Is it foggy when you look outside? F-O-G-G-Y. Is it snowy when you look outside? S-N-O-W-Y. Check out the weather, what's it like outside? Check out the ground, check out the sky. What word would you use to describe what you see? What is the temperature, how many degrees?
And while we're at it, let's look up with our eyes, cause anything that falls down from the sky is precipitation. What a weather sensation. It usually starts with a cloud formation. Gas turns to liquid during condensation. Well, that's the scientific explanation. But rain is what you see fall down, and there's other types too coming down in your town, like sleet, hail, or even snow. Precipitation, you should know. Anything and everything that comes from the sky, get your umbrella or stay inside.
Check out the weather, what's it like outside? Check out the ground, check out the sky. What word would you use to describe what you see? What is the temperature, how many degrees?
All right, I hope you enjoyed listening to the weather song. Now let's take a minute to think about what is weather. Weather is what the sky and air are like outside at any time. So if you went to the window or to the door right now, you looked outside, looked at the sky, and felt the air, you could tell me the weather. Now, we know that the word meteorologist means a scientist who studies the weather. You are a meteorologist this year, and we are going to keep thinking about how weather and sunlight can affect temperature. Temperature is how hot or cold something is. So, we've been talking about this playground problem. At Carver Elementary, in the morning, the playground is too cold. And at Woodland Elementary, in the afternoon, the playground is too hot. Today, we're going to talk about a model, which is something that shows how something else works. We're going to talk about this model and how it can show us how sunlight affects temperature or how hot or cold something is. I'm pretty sure you probably already know a little bit about how sunlight affects temperature. I want you to think, when there's sun, does that make it hot or cold? Keep that answer in your mind while we talk about this model. So, like I said, At Carver and at Woodland, it's cold at nighttime, but that's okay because no students are on the playground in the nighttime. In the morning at Carver Elementary, it is too cool for the students to play, but at Woodland, it's warm and the students feel comfortable. In the afternoon at the Carver playground, it's warm and the students want to play, they feel comfortable. But the Woodland playground is too hot. So we need to keep thinking because last week we learned that the weather at these two playgrounds are the same. So the weather is not the only reason that they're having this problem where this place is too cool and this place is too hot. So we're going to keep investigating. We are going to try to find out more about why this could be happening. So we need to ask, why do playgrounds or other places on Earth get warm? Why do playgrounds or other places on Earth get warm? I want you to think about that. If we're talking about an outside place, how could it get warm? So when we set up a model, we are going to show how something works. This lamp here is representing the sun. It's going to be here and here. And these pieces right here are some black rubber. In between the rubber, there's a thermometer. So we are going to figure out what effect this sun, this light that's acting like the sun, has on the temperature of the ground. And this black rubber is going to be our pretend ground, our model ground. Now, if our light, our sunshine, is not shining, think about what that would mean. If the light is not turned on, what might that mean? Think about it. When is there no sun? This is going to represent nighttime, when there's no sun shining. If the sun or the light is shining, when do you think that is? That's representing daytime. So when the sun or the light is not shining, this is showing us what the temperature would be at nighttime. When it is shining, that's showing us the temperature at daytime. Now, I want you to think, which rubber, which surface do you think would be warmer? The one that is not shining at nighttime or the one that is shining in the daytime? I want you to think, which one would be warmer? When the sun is not shining at nighttime or when the sun is shining in the daytime? If you're not sure, think about the temperature or how hot or cold it is when you go outside at nighttime when there's no sun and when you go outside during daytime when there is the sun. Let's look at what temperatures came up after we had one not shining to show nighttime and one shining to show daytime. The temperature of the nighttime model was 72 degrees. The temperature of the daytime model was 84 degrees. 84 is a bigger number than 72. That means this side was warmer. It was hotter. So I want you to think about this, and you are going to go over to the classwork tab and answer some questions on lesson 5. You're going to answer which was warmer, the nighttime model not shining or the daytime model shining. When the sun shines, the surface gets warmer or colder, and it is warmer in the daytime or nighttime. I want you to think back to this model where the not shining light was 72 degrees, a colder temperature than the shining light, which was 84 degrees to show the daytime. Head over to the classwork tab, answer these questions, and keep it in your brain for next week. Great job, meteorologists. I'll see you next time.